Good morning, students. Today we'll learn about the electromagnetic spectrum and electromagnetic spectrum. As we know that the electromagnetic spectrum has the various waves and rays, and they have the different energy level and wavelengths. So now we'll start. Uh, as we know that energy is equal to h nu, where the h is the Planck constant and nu is the frequency. And we know the formula of frequency and nu is equal to c upon lambda. Where the lambda is wavelength. Lambda is wavelength. So relationship between the energy and lambda is the inversely proportional. Inversely proportional in the sense if wavelength will increase, then energy will decrease. Vice versa, if energy is increasing, then wavelength will decrease. As we you can see in this picture spectrum that here wavelength is here the wavelength is more, here wavelength is less. Then again, and like this wavelength is decreasing in this direction. Wavelength is decreasing trend. Okay, and this and in that is as per this relationship. If wavelength is increasing, then energy will have reverse relationship, means in this way energy will decrease, means decreasing power. So in first you can see, and this one is the light spectrum. What is this? Light spectrum. Radio waves has the more wavelength but less energy. Microwave has more less wavelength in comparison to radio waves, but it has more energy in comparison to radio waves. Like this visible energy, this was a visual energy versus visual light. Visual light less has the less wavelength, but in comparison to infrared, but has the more energy in comparison to infrared. Like this gamma rays, it has the least wavelength. What is this? Least wavelength, but it has the max energy, maximum energy. So we can now we'll learn about one by one waves, the general brief idea. And this one, radio waves. This one, radio waves. What is it? Radio waves wavelength, means lambda. Wavelength is 1 millimeter to 100 kilometer. You can see the range 1 millimeter to 100 kilometer. And energy least. It has the least energy. रेडियो एंड इट इज बीइंग यूज्ड, मींस ये कहाँ पे प्रयोग होती है? रेडियो प्रसारण में, मींस आपका रेडियो ब्रॉडकास्टिंग में इनका यूज होता है. देन माइक्रोवेव. माइक्रोवेव इज microwave wavelength is 1 millimeter to 1 meter. So this is the narrow band, 1 millimeter to, in comparison to radio wave, 1 millimeter to 1 meter. And microwave's wavelength is 1 millimeter to 1 meter, and it has energy in medium, and it is being used in microwave oven. Used in microwave ovens. And next is the infrared. Infrared, infrared has the wavelength 700 nanometer. You could, as you know, the nanometer is the 10 to 9, 10 to power minus 9 millimeter. 10 to power 9 sorry, not millimeter, meter. Yeah, or you can say the 1 upon 10 to power 9. So this is a 700 nanometer to 1 millimeter. And is the heat, that energy is less. Energy is less in compared to the visible light, and it is being used where due to the infrared we feel heat. Then next is visual light. Visual light, and wavelength is 400 not 400 nanometer. 400 nanometer. This is a violet color to 700 nanometer to red. Means we have the spectrum as we have seen in this slide. Again, you can see here this one. This was the spectrum, light spectrum. Here is red. This is violet. That is the big said over here. So 400 means wavelength is maximum of violet color and least is red color. That's why all signals, signals are used being used in a red in color, so that it has the maximum wavelength. Maximum wavelength, and it can be seen from the far away. And energy, visual light has the energy between medium to high, and it is used for in energy is used for different colors has the different energy level. Then another is the ultraviolet waves. Ultraviolet waves have the wavelength is 10 nanometer to 400 nanometers, and energy is high, and it is being used in sterilization and tanning of skin. Then next is the X-rays. X-rays has wavelength point decimal zero 0.01 nanometer to 10 nanometer. Energy is very high, and it is being used in medical imaging, treatment for medical imaging, and security scanning. Like you can see the airport, and now nowadays they're being used at the various railway stations. That at the VSM baggage scanner machine. If you will put your baggage inside, and everything will be scanned, and security personnel can monitor through this VSM machine. Another is a last means the seventh is a gamma rays. Gamma rays are the wavelength between a zero point 0 nanometer to zero point 0 nanometer. So it has the very means it has the energy is very high, means maximum energy. Gamma rays has the maximum energy, and it is being used to treat cancer, nuclear physics. So this is all about the electromagnetic spectrum. If any student have any doubts, can comment on this video. And if you like this video, comment, like, and share. Thank you.